Okay, so I am live with 52 weeks of AWS, and this time I'm going to dive into Solutions Architect Part 2. I went through, I believe, a couple of the slides from last week, but we're going to dive right back in and keep going for Solutions Architect. I think storage is where I wrapped up last week. So I'm going to go ahead and share my screen here and get right in. Let's go ahead and do that. Okay, so we got inside of our ecosystem here, we got something set up here. I'm inside of this GitHub repo called AWS Bootcamp. And then inside of here, I'm going to go to this section, AWS SA slides or Solutions Architect slides, dive back in. And I believe I left at module 3 before because it was a really large PowerPoint slide. So I'm going to go into module 4. Hopefully this opens up. If it doesn't, I'll just switch over to PowerPoint. I don't know what the limit is, probably 100 megabytes or something like that for Google Slides. Okay, so we're good to go. Got that thing working. That's always nice. So to start with, adding a compute layer, we're going to talk about, basically how do you do this inside of AWS. And at the end, you'll know how to work with EC2. So to start off with here, in terms of your architectural needs, a few things to think about is compute is a large part of the architecture. In fact, if you don't have compute, it's pretty much almost impossible to do anything. It's one of the most important components of cloud computing. And you can see in this particular example, there's a Amazon EFS, Elastic File System, mount point. It's mounted on EC2 instance, virtual machine. And then we've got a static website as well, and a user is able to use it. And in this particular example, this is a cafe that wants to display both static content and also dynamic capabilities. So let's go into AWS runtime compute choices here. We've got virtual machines, and that would be Elastic Compute, right? EC2. The EC2 is nice because it has so many different categories. And then when we have Lightsail, that's also a VM-based solution because it's a platform as a service, but allows you to do things like, launch a WordPress site. For containers, we've got Amazon Elastic Container Service, or ECS. For platform as a service, we have AWS Elastic Beanstalk. For serverless, we have AWS Lambda and also AWS Fargate. For specialized solutions, we would have AWS Outposts and also AWS Batch. So there's a whole variety of different runtime choices, and each one of them is going to have a unique capability. Now, notice on the bottom here, you can see that there's higher infrastructure control and customization on the left, right? Because it's the raw, ecosystem. But then when you go to the right, it's actually faster application deployment. So really, as a architect, you have to choose: do you care more about control and performance potentially, or do you care more about like the ability to deploy code as quickly as possible? I personally, at this point in my career, am shifted more towards caring about building applications, but it really depends on the environment you're in. So EC2 allows you to resize compute capacity in the cloud. You work with virtual machines. You can provision these things in essentially minutes. They can automatically scale up and down through basically adding auto scaling to it, and you only pay for what you need, and you actually don't have to worry about being charged for more than you're using because it's got per second billing. The EC2 instances here, you can see this is an EC2 instance that's on a VM, and you can choose things like CPU, memory, different storage options, instant store, EBS, network connectivity, hypervisor, RAM, CPU. All this stuff is part of the EC2 instance here. And once you have an EC2 instance, you can also use services like AWS Amazon EBS. So what are the use cases if you want to have complete control? So if you do want to go in and patch Linux, for example, tweak Ubuntu, go ahead and dive into it, then that would be one option. Another one would be for optimizing your compute costs. So if you want to switch between on-demand instances, reserved instances, spot instances, savings plan, you could kind of dive back and forth between those. Also, the ability to run any kind of workload. So simple website, enterprise application, HPC, basically it's an all purpose, generalized environment for doing computing. So that's probably one of the capabilities to be aware of. You can do web server, application servers, database servers, anything. To provision it, the essential components here are all important, and it's important to know that these can all trip you up. So for example, when you launch an instance, if you don't have the correct security group, you won't be able to talk to it because you need to open up, let's say, SSH. Also, if you don't have a key pair and you're using SSH to communicate with it, you're not going to be able to communicate. So you have to have, there's some prerequisites to launch it. Also, you need to know what kind of image you're going to launch. Are you going to launch Amazon Linux 2 or Amazon Linux or Ubuntu or your own custom AMI that's got your company's software inside, and then instance type as well? Do you want essentially GPU heavy machines or storage heavy machines or CPU heavy machines? And then what kind of storage do you want? Do you want elastic block storage? Do you want instance storage? User data? So are you going to inject things inside? What about an assumed role? Are you going to basically allow this thing to talk to a key component of your infrastructure? And then VPC, so network placement and addressing. Okay, so what about choosing an AMI to launch for an EC2 instance? A couple things to be aware of here is that there is a template for the root volume, and this contains the guest OS and other installed software. You can also have launch permissions, so you can control, who in your company can actually launch AMIs, and also block device mapping. So, what are you actually attached to the instance? You can also create multiple instances from the same AMI as well, which is pretty nice, right? You can have basically a golden image, and then make multiple copies of this. Why would you care about an AMI? Repeatability. So you can repeatedly launch instances with efficiency and provision. Reusability, right? Instances are launched from the same AMI. Recoverability. So you can create an AMI from an instance and then replace it very easily because it's got the exact same image. So the repeatability is, I think, a huge component, or the 3 R's here: repeatability, reusability, and recoverability. What about choosing one? Which one should you choose? A few things to consider: region, what kind of operating system, Windows or Linux, what's the storage type, and architecture and virtualization type. In particular, I would say if you don't know, most of the time, I would recommend you probably use Amazon Linux, the latest version of it. Instance store backed versus Amazon EBS backed AMI. Well, a few things to be aware of: that in terms of EBS, it boots faster. It also has a larger root device size, so you can have a 16 terabyte EBS root device, which I don't know why you'd want one for your root device that big. I think it'd be much better to split it up, but you can. You can also have the ability to stop the instance. You can change the instance type by stopping the instance, and you're charged by the usage. The instance storage is a lot longer to boot. You can't make as big of a root volume. You can't stop it. You can only reboot it or terminate it. So the other thing is that you are also charged for instance usage and storing your AMI in S3. So there's some interesting components between the two different flavors. And then the life cycle for when you're launching an EC2 instance is that you first go through and you launch an instance. It goes into pending state. Once it's running, you have some choices. You can either stop it in the case of hibernation with EBS back storage, or if you want to terminate it, you can also just directly terminate it. In the case of the ephemeral or the instance backed, you have only one choice, which is to terminate it. You also can reboot. So how would you create a new AMI? Well, the core idea here is that with an AMI, you can import a virtual machine, bring it inside. Once you have that, modify it, put whatever changes or scripts inside of it, maybe upgrade it, then make a copy of it by making a new AMI. And then that AMI, you can actually move that into the regions that you want. And so the advantage of something like this is you can get it all configured for, let's say, a cluster of Spark machines. It'll be exactly the way you want. EC2 Image Builder allows you to automate the creation, management, and deployment of up-to-date and compliant golden VM images. So the golden image has been around for quite some time, decades. But the concept here is that you create this image and everybody in your cluster can use it. And there's a tool on AWS called the EC2 Image Builder tool, provides secure, validated, and up-to-date images, enforces version control. So how does it work? Well, in a nutshell, the specified source image here, what it does, it allows you to, basically start with some base, add in some components to it, do some hardening tests, make a build schedule to specify how often you're going to build this image, and then do an automated distribution policy. So this creates the golden image. Okay, so what about selecting an instance type? This is always an interesting one because you don't want to pay for more than you need, and you also don't want to have an inefficient instance that's just kind of churning there, can't do its work. So a few things to consider is that it's going to be a configuration of CPU, memory storage, and network performance. So for example, if you wanted to have 4 CPUs and 16 gigs of RAM and, maybe a SSD storage and 10 gig network performance, you could go through and select that as, your size. The naming structure is basically generation would be the second digit. The first digit is family. So M5 would be family M generation 5. And then D would be additional capabilities like, for example, storage-based capabilities, and then size is X large. So M5D.X large shows just everything we need to know about that instance type. So the suitability of instance types for workloads, general purpose is for just gaming, caching, dev environments, web servers. Examples would be an M5, T3, A1. What about compute optimized? What would you use those for? Were batch processing, distributed analytics, high performance computing, HPC, ad server, multiplayer gaming, video encoding. Examples of that could be a C5 or C5N. Also memory optimized instances. So this would be, in-memory caches, high performance databases, big data analytics. That would be R5X1 or HMI. Accelerated computing instances. This would be ML, AI, HPC, graphics. This would be P3, G4, and F1. And then in terms of storage optimized instances, this could be high performance databases, real-time analytics, transactional workloads, NoSQL, big data warehousing, log processing. Basically by using these things, you could also work with search engines. These are high disk I/O examples. That would be I3, or dense storage would be D2 or H1. So how do you choose this type? Well, the big thing is performance and cost, right? Those are the two factors to kind of go back and forth on. And so when you create a new instance in the EC2 console, this allows you to select what type you want. And in particular, there's essentially 270 available instance types, and you just have to choose which one you're actually wanting to use. Now, in terms of AWS Compute Optimizer, this is something that allows you to pick the optimal instance type, size, and scaling group config. This will look at the workload patterns and make a recommendation, and it classifies instance findings using under provision, over provision, optimize, or none. So that is pretty neat, is that you can actually go ahead and have it take a look at what you're doing in production, and then it can actually optimize for you. All right, what about using the user data section of EC2? How would you do this? Well, when you launch EC2, you can actually inject inside the user data. And I've actually done this in the past here. In fact, why don't I just show something in GitHub where I have an example of this thing. I go to Spot Price ML. Several years ago, I wrote a book called Practical ML Ops. And inside of it, I had an example here for Spot Launcher. And this is just an example of, one of the things that you could do. Like if I wanted to launch a a test spot instance, right? I could say, hey, go through here, put in some user data. And now notice what I do using the user data command is I say, listen, I want you to halt at some duration automatically. So this was a neat little trick, which is you put a kill switch in so that it'll only run up to some period of time. And that way you don't accidentally leave it running. So for running spot instances, I think having your own startup script like this is a kind of a cool concept. And also notice that I can actually pass in my own AMI. We're just talking about AMIs, my own security group, basically profiles, right? For, giving it the correct roles. And then I could actually just, tweak even the volume size and all kinds of other things using the Bodo command. So basically it fits pretty well with like full automation of scripting a spot instance launch or even a on-demand instance. So you can also retrieve the metadata of your machine as well. And you could put that inside of user data. So you could basically say, hey, when I launch, I want you to spit this out somewhere, maybe put it in DynamoDB and, so I can know what's happening. Because when you launch an instance, if you've launched it like essentially without looking at the console, you may not know yet what the IP address is of the machine. So to configure an EC2 instance, there's AMI versus user data. And so, in the case of an AMI, it would be fully baked. But in the case of user data, you're cooking a little bit. So it's almost like you're cooking some cookies that were mostly cooked, which they do sell those. And it takes, just a few minutes to cook the cookies. Okay, so user instance with user data. I could actually take a look at this and show people why not. Let's go ahead and do it. So if I go to console here and I dive in, we can log into my account. And a couple things to be aware of here. Let me just get into my auth code here. So okay, so if I want to launch an instance, what I would recommend is go to EC2 first. And then I would actually go to spot request. I think that's the best way to go. And the reason why is if we look at pricing history, you can get pennies on the dollar, right? So if I go through here, I can see I can get things for 70% off if I get a C3 large here. So why pay full price? Why not be thrifty? So let's go ahead and request a spot instance. I'm going to pick Amazon Linux 2. I've got a key pair here that I could use to SSH into it. And then if I go through here, this is the total target capacity, which is 1 right here. And then I could even set a maximum cost if I wanted to, which is kind of cool. And then basically, if I scroll down here, this is where I would put in, either manually select an instance like this, or I could specify the attributes that match my criteria. Well, I mean, it just really depends on what it is you're trying to do. Now, this one, we can see that's a pretty good deal. Like if I want to go just for who's going to give me the best deal for the most powerful machine, like, look, this has 15 gigs of RAM, 2-core machine, and I get 80% off, and I only pay 3 cents an hour. I like it. Let's go. And then I can go through here and just say launch. And I could even pick on lowest price, launch spot instances from the lowest price instance pools. If I want to be lowest priced, let's do it. So this is going to go ahead and create a spot request. And this takes just a second or so to submit it. Once it's fulfilled, then it'll change the state here. So let's go ahead and see this. Give us a second. There we go. So it's active. And then if I go to the request ID, right, it shows me everything that's associated with that request. Now I can see here's the instance that it was able to request. And now if I click on the instance, we can see it's in pending state. So this takes just a second or so to get inside of here. And we can see everything that's happening. And if we go to security groups as well, we can see that port 22 is open. And so I could SSH into this thing if I wanted to as well. So let's just give this thing a second, see if this thing will launch. Not a big deal if it takes a little bit of time to launch, but I can also go to instance state and go to pending, and here we go. I've got a micro running from a while back. This was a good example of something I'd set up before, and I just forgot to kill it. So I'm going to go through here and I'm going to take this instance and I'm going to basically instance settings. I'm going to go to, let's see here, terminate instance. There we go. Terminate instance. And then the next thing I'm going to do, so this thing's been terminated, is I'm going to go back to my other instance. There we go, running. And I could even give it a name and just say like, spot, so I don't forget it. And then from here, I should be able to see that it's in a running state here. And I can even look at the type and everything. So this is a T2 large. This looks good. It's still in initialization stage. So in order to connect to it, I would need to know its public address. So I can just copy this public address here. And I could SSH, or I could just say connect like this. And I could use the EC2 instance connect here. That's one way to connect to it. Or I could use session manager, or I could do SSH, or I could do EC2 serial console. Those are all different options that we could use. I think I will do this one. Let's see, instance connect here. Let's try this one. And what's nice about it is, there we go. Now I'm able to log in. And we can say like, who am I, right? And we know it's running EC2 user. Now to get rid of this thing, how would you get rid of it? So you need to go back to spot request here. And then notice that in this particular spot request, I could just select this and I could say cancel request and just say terminate instances associated with those requests. And then this will actually cancel everything and clean it up. So pretty straightforward actually to use EC2 instances. And then user data would be what I talked about before, is I could also launch something and pass it in like this. Okay, let's keep going here and get into the next sections. So what about adding storage to an EC2 instance? You have the root volume, and this is where you would have the guest OS. You also have a data volume. So this would be for accessing, single instance data. If you want to access the same data on multiple, there are actually two options. There's the Amazon FSx, which is pretty cool. And there's also EFS. And these both allow you to do basically multiple machines can mount the same thing. In terms of instance store, this is a non-persistent storage to an instance. The characteristics are it's temporary block level storage. It uses either HDD or SSD, but the instance data is lost when the machine is stopped or rebooted. Examples are buffers, cache, scratch data. EBS is network attached storage. So really the performance of your network is critical in terms of like how fast it will behave. And it's block level, it's in the same AZ. It can be encrypted, it can do snapshotting. Use cases would be like a database. Example, why would you use SSD? Just general purpose. It's just a nice balance for price and performance and for booting. But provisioned IOPS is something I've used before. And so if you wanted to have a really mission critical like graph database or something that you are tweaking and customizing, you could do provisioned IOPS and just special purpose it. HDD is low cost, and that's really designed for streaming or big data. There's even cold HDD, which is used for things like, cost is not important and you just want something super slow. So what about Amazon EBS optimized instances? What do you do with these things? Well, the benefits are it's a dedicated network connection, and as increases IO, additional performance is used if it's using the EC2 Nitro system-based type, and then it's for things like if you need speed and basically EBS optimized instances. So what about shared file types for EC2 instances? The ideal one would be to use EFS or Amazon FSx. And so the idea here is that the EFS provides Linux-based workloads, fully managed, scales up and down, petabytes of data. I've used this in production before. I really like it. It supports the NFS protocol, and you can mount these on boot. And then, although you can also mount those later as well. if after it's booted, and it's compatible with all Linux. Use cases would be, let's say you have the same home directory that's all mounted on these file systems for enterprise applications, application testing, database backups, web server, and content management, media workflows, big data analytics. I've used it personally for doing thousands of computer vision systems that were doing frame processing. So Amazon FSX for Windows file system. This is native Microsoft Windows tech. And in fact, it also can do NTFS SMB protocol as well. Distributed file system namespace and DFS replication, integrates with Active Directory. It's also backed by high performance SSD. So why would you want to use it? You would use it for home directories, lift and shift, media and entertainment, data analytics, web serving, software development. So in a nutshell, there's a couple really good high performance file systems that you can use that are shared. So in terms of EFS, I mean, just I guess the few things that I would mention here for EFS is it's actually not that bad to set up. If you go to my AWS account here and I type in EFS, all you need to do is you can see I've got several created here. I could just go ahead and create some file system, choose whether it's regional or it's one zone. And then once you've created that file system, you can go through and just mount this file system, and it'll give you actually the attached commands. And look, it tells me exactly how to mount, this file system. So there are a lot of things to like about the EFS. It's very straightforward to set up. There are some things that you can do though, like for example, you can do bursting or provisioned. The advantage of provisioned is you can actually pay for better performance, which in some cases could be what you want. Okay, what about pricing options? The main pricing options to consider for EC2 are on demand. You pay by the second or hour, no long-term commitments, spiky workloads, or experiments. That's when you'd want to use these. Reserved is if you really do know what you're doing. You have a fixed capacity, you get 1 or 3-year commitments, and you get a huge discount because you can buy in bulk. Savings plans are like reserved instance, but they have a little more flexibility. If you say I'm going to, have a per hour commitment, you can use that with Amazon EC2, Fargate, and Lambda workloads. Spot instances is what I use a lot for prototyping, and it's up to 80-90% off. You can do stateless workflows, flexible, fault tolerant, also for prototyping. A dedicated host would be a physical server with EC2 instance capacity for your own use. And so, in a nutshell, I think, if we look at the differences here, dedicated instances would be per instance billing, automatic instance placement, isolates the host that run your instance, but a dedicated host is per host billing, visibility of sockets, cores, and IDs. And a benefit would be you could use like a software license server. The EC2 cost optimization guide is really basically things like the number of instances and the time, and then you combine all those to purchase what you need. And so the reserved instances or the savings plan are for the steady state, and then the on-demand instances are for the spiky workloads, and then you can scale up and down with spot instances. So what do we got left here? Just a little bit more left, and that's going to be considerations. So placement groups are one consideration. So you can use those to control where the instances run in your AZ, and they can depend on, they can create interdependencies like network performance or reduced correlated or simultaneous failure. Also, placement strategies. So do you want to cluster, partition, spread? What about limitations? There's an instance can be launched in only one placement group at a time. Also, instances with a tendency of hosts cannot be launched in a placement group. There's also cluster placement groups, and this would be low latency, high packet per second network performance in the same AZ. Also, these instances are placed in the same high bisection bandwidth segment of the network. They provide per flow throughput up to 10 gigs a second with TCP/IP traffic. Also, it's recommended for applications that benefit from low network latency or high network throughput, or both. And the best practice is launch all the instances in a single request. So clusters do require special capabilities, and there are specific cluster placement groups. Partition placement group would be, this is when you want to essentially reduce the likelihood there'd be correlated hardware failures. And so each partition has its own set of racks, own network power supply, and they can be multiple AZs. So this is a good idea if you wanted to just further kind of tweak the distributed nature of your application. Spread placement group is actually a way to reduce correlated hardware failure. Groups can span multiple AZs, and they're recommended for applications that have a small number of critical instances. So basically, in a nutshell, the main takeaway here with all this stuff, since we're pretty much done, and I'll just go back to my own console here, is that with compute, there's a lot of options for Amazon, and I think one of the best ways to get an understanding of it is spot instances, especially if you're using spot instances where you're using user data and controlling it from either a script or Python or whatever it is you're building. In a nutshell, the more you play around with spot instances, Lambda, the different compute options, I think the better handle you'll have on using the AWS EC2 ecosystem. All right, so next week I'll be back again to do a little bit more on the solutions architect material. And I believe I will cover next week. I believe I'm going to cover, let's just go ahead and pull this up to make sure we're on the right page here. But basically, we wrapped up EC2 today. And then next week is, what is in module 5 here, is adding database layer. All right. Thanks again. I will see you next week.